being here today, and thanks to the committee for selecting my talk. It's definitely an honor. Oh, brilliant. It's been a long time since I've been back to Wellington, so it's really lovely to be back. And yesterday I saw the sun, so I think I've heard that's kind of a rare treat. A little bit more drizzly today, but I grew up in America, as you probably can tell. I live in Australia, but I grew up in America, so I'm very used to very drizzly and cold days. So my name is David Peterson. I'm a principal solutions engineer for Confluent. I've been with Confluent for a little over 5.5 years, so quite a long time. I was the third person for Confluent in Asia Pacific, so I kind of helped to start the region, and used to be back in New Zealand a lot. So with the BNZ team, I heard a nice cheer earlier, and the ANZ team, I've had quite a few meetings. And if I get a chance, with time, I've got a demo to give, and you'll actually see I work with the ANZ Bank so much, I've got a tab on my Chrome with all the ANZ URLs that I do. So this talk is going to be about three main areas. It's going to cover the Kappa architecture, stream processing, and generative AI. Show of hands, has anybody heard of Kafka or used Kafka? Oh, wow, OK, excellent. And anyone heard of the Kappa architecture? Brilliant, great. Well, I've got a job ahead of me then. I think this quote is really interesting. I actually came across this quote from Twitter, or X now, unfortunately. I still have mine on my phone. I still have the Twitter app. I haven't updated it because I just can't do it yet. But I think this talk is really about being open and being receptive to new things. And I really like this quote. It's, no matter what the future we may envision, it relies on software that has not yet been written. And I think it's really good to think that and really sit that in, because oftentimes we sort of just jump into a project and use the tools that we have. But we should realize that it's a new possibility every time we embark on something new. And I came across this by Grady Booch, who was talking about there should be a UML tool for AI so that we can kind of discover what's going on. And somebody on Twitter replied, dude, if you knew anything about UML, you would know that it already does that. And then he replied, dude, I invented UML. So it was sort of like the classic Twitter debate, kind of things like that. So anyways, I thought that was quite funny. And I think this talk is really all about curiosity. And I was at a dinner last night with a speaker dinner, and BMK mentioned that, and you heard it earlier. I think being curious is always really important. And this is a diagram from Wait But Why. And I really like it because oftentimes we think of ourselves as our life, we sort of maybe regret decisions or not regret decisions, but we sort of think like all these paths that have ended and we're at where we're at. But what we don't realize is that that's only today, and tomorrow we actually have sort of an infinite number of paths that we can kind of traverse on. So I think it's really, again, important to stay curious, to realize that we're always able to learn, we're always able to kind of explore new areas, and the future is something that we don't know what's going to happen yet. And so I've tried to paint everything together into a little bit of a narrative or a story, because I always think it's a little more interesting. And so in this, we'll be following a very young shoe company. And it's a little bit of inspiration from my youngest son. He loves shoes and designing shoes. So this is something that is incorporated through the rest of the talk. But what we have is, sorry, my laptop's going to fall asleep. I didn't put it on power mode, sorry. There's a story of a young designer and a young developer who are embarking on creating a shoe company. And because they're sort of new to this, they've been doing a bit of research and different things. And effectively, the developer has used tools in the past. They've used a lot of traditional tools. And they've come across the Lambda architecture. And they've used that in the past with their various projects. And so the Lambda architecture really is all about choosing one or the other path. You sort of choose the fast and slow path, maybe sometimes called the speed layer, or oftentimes you'd use the big and slow path for your larger projects. And really what the Kappa architecture is all about removing a lot of these barriers and allowing you to sort of just tackle any new project or any new application in a much more open-ended way. And it's built on top of of Apache Kafka. And so Apache Kafka, of course, is quite well known. I saw a lot of hands earlier. And I think one of the things that really bothers me about Apache Kafka is the fact that it's actually used so much. And what I mean that is it's used so much in a very particular way, sort of as a very much, as a kind of a dumb pipe. And it's used to produce and consume messages. It's used kind of as a message queue replacement. And oftentimes, it begins and ends very quickly. And the reason for that is that's why it was created originally. It was created at LinkedIn to do just that. But as those diagrams I was showing earlier, times change. And again, this is a fortune cookie I got, gosh, it was probably 5 years ago. I was just at a restaurant with my brother. And the usefulness of a cup is in its emptiness. And that really caught me, because I was expecting, oh, you'll win $1 million, or you'll meet somebody or whatever. And I thought it was kind of an odd fortune cookie. But the more I thought about it, I really liked it, because it really, you think of a cup and you just don't really think about it. You just drink. And I think the corollary there with Kafka is we use Kafka and we don't really think about it. We just use it. But the usefulness of Kafka is in the fact that it's not only the things that I said earlier, but it's actually a lot more of what's possible. And some of the three key pillars of what it does is really publish and subscribe, which I kind of talked about already. I don't really need to cover that at all. It's about storage. So this is sort of kind of breaking a little bit of what we're used to, being able to store events durably in Kafka. And so this pattern is being used more and more. They're working with a number of banks in Australia that are building payment systems on Apache Kafka. And they're storing all the events for at least 7 years. So again, this is very different than the default of 7 days, and sometimes even like 7 hours. And then lastly, processing. I won't touch too much on it right now, because I'll be talking about it a lot more. But these three things combined really create what is the Kappa architecture. And it is surprising to me how little information there is on the Kappa architecture. But again, that's why I think it's probably part of my duty to come to as many events as possible and talk about it. But the Kappa architecture was originally created by Jay Kreps. So Jay Kreps was one of the 3 people that created Apache Kafka at LinkedIn. And back when he was still at LinkedIn, he coined the Kappa architecture. And it was sort of a response to the Lambda architecture. And there's a lot going on here, so I'll try to kind of break it down really quickly. But really, it's all about the producer being able to produce information at any rate, and the consumer being able to consume at any rate, and they're fully decoupled. So that means that the producer is optimized to produce events. Sometimes those can be 1 a day, or it can be trillions of events per day, which we have a number of users of Kafka are in the trillions of events. Sorry about that. I'll just remind myself to move the cursor there. And it's fully decoupling the producers from the consumer. You'll see sort of there's also Kafka Connect. Kafka Connect, again, there's hundreds of connectors available, so that means that you can just quickly onboard new data or consume new data. You're also talking about schema. I haven't included that in this diagram because it was getting a little bit busy. But the other key aspect of what a Kappa architecture is you're treating events as a first-class citizen. And to do that, they need to have a schema attached to them. And as soon as you do that, you start to reason on those events differently than if you're just pumping data through as a binary or as a blob. And the critical aspect of that is your consumers now have a contract that they are guaranteed to have as they're consuming. And so that means that you can create consumers and those consumers know that that data product will last for as long as possible. And interestingly enough, too, you can include schema transformation, meaning that you can evolve your schema over time, and yet any existing consumer can still continue to consume at the whatever schema that they chose to. And then again, as I've talked about, there's a bit more in stream processing. And so what this is doing is it's sort of opening up a little bit of 2 different worlds here. There's sort of the old world, which is effectively an event processor. And so an event processor is, again, what we probably all typically use Kafka or tools like MQ-type tools for, which means that we're dealing with a single event at a time. And we're subscribed to something, or we're handling an event at a time. Whereas the change to that is really the stream processor. And the stream processor, what it's doing is it adds the notion of handling more than one event in more than one topic at a time. And it's doing that by incorporating time actually as a key primitive. And so I'll kind of describe a little bit of what the stream processor is doing. And with Apache Kafka, the streams API is built into Apache Kafka, and it's made up of 3 key primitives. One is the topic itself. So a topic, of course, and this section has to do with animation. I've always loved animation, and this particular uses Studio Ghibli movies, so hopefully some people in here are familiar with them. But we have here, we have 3 topics. So we have the cat bus from Totoro, we have Ponyo, and then we have the family, the father from Spirited Away. So each one of these is a topic. There's data flowing in, and as we continue. And if we were to sort of zoom into one layer or one frame of that animation, and again, so this is traditional, digital animation would be quite different now, but I have a little bit of a soft spot for traditional animation. And traditional animation was done using layers of transparent sheets. And so what we're doing here is we're taking those apart, and as you can see on the bottom, we've got the background, at the top we've got the foreground, and then we've got the characters in the middle. And so if we kind of bring this back into how does this relate to an event, so what we've done is we put them back together again, and now you can see the 2 actors. We've got our raccoon and our bear, and you can see some basic XY coordinates. So you can imagine in this really terrible animation software, we'd be able to be putting these images into a different topic. We'd have the background, which would be fixed, the foreground, which would be fixed, and then the characters, you'll see they're moving and the XY coordinates are changing. So again, this is my animation skills, so it's very, very not impressive, but hopefully you get a picture. The second component of the Streams API is a stream. And that sounds a little bit odd. You know, the stream itself is the component of the Streams API. But what that's doing is it allows us to take those series of single events. And so here you can see some frames from Totoro again, where there's those little dust creatures. And each one of these, again, is a frame of animation. So again, these are all events that are occurring. And what it does is, sorry, I told myself I would set my laptop up to not power down, and it didn't do that, so sorry. And what the Streams API does is it adds sorry, it's throwing me off a little bit. What it's done is it adds the ability to add time to a topic. And so therefore, you can play and replay that topic back and forth. And the third key component of the Streams API is the table. And again, that kind of sounds a little bit odd, like why is a table part of the Streams API? But you can see that in animation, there's kind of the corollary is the exposure sheet. And so again, in traditional animation, what they would do is they'd actually break down the animation into all the single mouth shapes, all the different actions that they would take. And so again, they would take this animated film and show what it looks like into a table format. And that has the corollary in Apache Kafka, where we have, for instance, a table here on the left-hand side, and then we have something like a change data capture changelog occurring. And so really what Apache Kafka, or the Kappa architecture, sorry, is you may have maybe come across or heard something called the database inside out. And so what Apache Kafka is actually it's the database inside out, meaning that every database is actually backed by a changelog. It's just that we interact with the table. But in fact, it's actually the log itself is what drives the database itself. And with Apache Kafka, what we're doing is the changelog becomes the first-class primitive that you work with. And so here what we're doing is you can see that we've got a table. And so we have Alice, she's scoring a point. Then we have Charlie, who scores a point. And then later Alice scores another point, and then Bob gets added. And each one of these things are an event that are occurring. And you can see that in that stream. And then on the right-hand side, you can see that now we're able to recreate that table from the stream of events occurring. And this is called the stream table duality. So it's being able to take something from a table, going into a stream, and back into a table. And again, this is really important when it comes to the Kappa architecture, is because we are able to then materialize different views into your topics, meaning that we can materialize any state as it stands in any moment. And you'll see what that looks like in a Customer 360 example really soon. And so that ends the part on animation. And so this brings us into the Customer 360. And so as I talked about earlier with the Kappa architecture and the ability for those producers to produce any amount of data as they need to, it's really about, if you think about data again itself, it's really about kind of being able to take in any type of data. So whether it's fast data, maybe point-of-sale data, or real-time IoT data, just-in-time data, which might be a customer updating their record or updating something, or maybe going into the website and ordering something, so kind of just-in-time actions that are occurring. And then lastly, batch, which is very typical in terms of nightly batch updates or hourly batch updates. So again, with a Kappa architecture, it doesn't matter. You can think of things as a data set, and the data set is either a bounded data set, which means it has an end, or it's an unbounded data set, meaning that it doesn't have any known end. And so therefore, you don't have to, again, in the Lambda architecture, you have to choose up front which one it is, whereas with the Kappa architecture, all possibilities are, again, possible because it treats everything as a data set, whether it's bounded or unbounded, or fast or slow. And you can see this is, again, just a very basic diagram. If I had had a little bit more time, I had originally thought the talk was 40 minutes, so I don't know what I was thinking, and I had to kind of compress something down a little bit. But I had a demo to show, so if anybody wants to kind of see a bit of a demo later on, come up and have a chat. But in this Customer 360 example, we have a number of source connectors. So we have purchases, we have loyalty, database, change data capture. Maybe I should stick here a bit closer. And then batch data. So again, we have real-time data, we have just-in-time data, and we have kind of slower batch data. And each one of those are flowing into a topic. And for instance, here we have a change data capture. So hopefully everyone can see that a little bit. But so this is a screenshot of the actual demo. And what it's doing is it's showing change data capture. So it's the before state and the after state. And so that's one data source that is flowing in amongst a few. And what we're then doing is we're using, in this example, I'm using KSQLDB, but we could also be using Flink or a number of different stream processing tools to effectively join those various data sources all together on keys on the customer ID. And again, the unique thing about this is the fact that because time is now a first-class citizen, we can join data that's slow, that's fast, that's late arriving, that's coming in, maybe in the wrong order. And the Streams API actually reorders everything for you. It takes care of those sorts of things so that at any moment you have the current state of what that customer is looking like. And so this is the actual KSQLDB query. Again, there's a lot going on here. But what I really wanted to point out was that it's just text. It's just SQL. So it's something that, again, it takes a little bit of knowledge around how to use it. But most of us are pretty familiar with SQL. So it's great that we can be able to take quite complex stream topologies and just use SQL to kind of craft that. And then what that looks like then is we then take that fairly wordy KSQLDB query, and we now write that to a new topic, to the Customer 360 topic. And again, you can see a little bit of an example of what that looks like, and I've highlighted sort of just the customer information. In the last slide, I showed that the before and after. So what I've done is I've cleaned up various data sources from the topics in the middle there, and then I've joined them together, all based on the key of the customer. And I've written that now to a new Customer 360 topic. And this also shows an interesting pattern that I see in the Kappa architecture around sort of this raw topics and enriched topics. So raw topics tend to be stored for maybe a day, 7 days, 30 days. And what you're doing is you're allowing for potentially any errors to be found or fixed or anything like that. But there's not as much value in those raw topics. It's really in those enriched topics where you get a lot more value and where you get a lot more kind of more of a data product view if you think about a data mesh. And so for instance, in here, we might only be storing those raw topics for, again, 7 days, 30 days. But really, the Customer 360, we'd be storing potentially for infinitely or as a compacted topic in Apache Kafka, which allows you to store data effectively forever on a key value pair. And this gets us into generative AI. So we're bringing everything in together. And you'll see there's 3 images here. So we've got fire, the wheel, and language. And I think one of the really interesting things is I've been doing a lot of work and research in generative AI. I don't have a machine learning background. I do have a stream processing Kafka background. But I think one of the really interesting things is, you wonder, well, why am I showing quite old things in regards to generative AI? It's because some of the most profound thinkers and researchers in AI have compared where we're at and where we're going to be potentially in the next few years as transformative as language, as fire, and the wheel. And when I say that, so Sundar Pichai, the CEO of Google, has said it will be as transformative as fire. Yuval Noah Harari, who wrote some really amazing books, has said it's going to be just as transformative as the beginning of language. And Geoffrey Hinton, who is considered to be the godfather of AI, has said it will be as transformative as the wheel. And all of those images were also generated through Midjourney. So it's, again, it's a pretty amazing tool, actually. If I should have lingered a little bit, well, actually, maybe I can get, if you look at the hands of the one guy sitting, you can see there's like an extra finger. So it's kind of the classic thing with Midjourney. But again, they're pretty convincing. And here's a couple quotes as well. So Ray Kurzweil, who's a very forward thinker, way back in 2014 put the date that he believes for AGI to be as of 2029. So things are looking a little bit more close to that, which again is a little bit scary. And then Ilya Sutskever, who is the chief scientist at OpenAI, back, I think about a year ago, tweeted this, which was I was quite shaken actually when I read it. But he says, in the future, it will be obvious that the sole purpose of science was to build AGI. And there is actually a lot of very profound, very forward-thinking, and very smart people who have seen it's almost humanity's responsibility to create AGI. So we're not there yet. We're sort of at ANI, artificial narrow intelligence. But AGI, again, is something where the AI will be generally as smart as effectively every individual. And so there are a number of, again, very leading people who are putting potentially dates, ranges from the next 2 to 3 years up to potentially about 5 or 10 years, and it goes all the way up to 50 or 100 years. But these things have all really been compressed from the relaunch of ChatGPT. And again, this is another really good example of how much things have changed. So this is just, again, using Midjourney, and there's a bit of a prompt here, which is street-style photo of a woman shot on Kodak. So this original photo is, it's not a photo, it's a generated image from Midjourney. It was from July 2022. And then the other one is from July 2023. So you can see the leapfrog in terms of quality from the image generating tools. And which takes us into the LLM. So I'll speed up a little bit because I know I'm a little under time. What I want to do is I want to quickly explain what generative AI is. It's really made up of kind of 3 key components. The large language model, which I was kind of talking about just briefly. It's also made up of fine-tuning, and it's made up of ultimately the prompt. And the prompt is where we kind of incorporate the Kappa architecture and allow us to utilize the full functionality of the large language model. And you can kind of think of the LLM as really the brain. What it is, it's sort of like, if we all think of our own brains, it's our life's experience, it's kind of all of our knowledge combined. But the big difference between an LLM is it's locked off at a certain point. So at some point, they have to lock off the training, and they have to then release it so that you can run inference on it. Fine-tuning, what it does is it takes that amazing brain, and it gives it new tasks. And so ChatGPT was built on GPT-3 originally, and when GPT was actually out for about 2 years, but nobody really used it or knew about it because it was not really generally useful. And when they started to fine-tune it, they gave it a new task, and that task was to chat. That's what they taught the GPT-3 model how to chat, how humans like to ask questions and hear responses. And so that's where ChatGPT came from, and that was really the explosion of interest in generative AI, and it became one of the fastest growing subscribing apps at the beginning, I think, ever. Maybe Threads might have changed that. And then lastly, the prompt. And in this analogy, the prompt is really kind of our daily life, your work, reading the paper, reading websites, whatever. So the prompt is what allows us to do like the day-to-day activities. And kind of zooming into that a little bit with the prompt, it's really kind of built up of things like, who am I? So when I say who am I, that's the LLM itself. So in the prompt, you're actually telling the LLM what it should be like. You should tell the LLM if they're, and you'll actually see that if I can get to it. You'll see that you tell the LLM you're a helpful assistant, you're a 6th grade teacher, and the LLM is like, oh, great, thank you. Now I know how to operate. You're also telling the LLM who you are, how I want to be responded to. You're also saying what's your history, like kind of your chat history, or how you've been interacting with the LLM. And then lastly, you're interjecting new knowledge into that prompt. And this is how, when you're using ChatGPT or any of the LLMs, it's really made up, the prompt behind the scenes is actually doing a lot of work for you. And interestingly, and again, I guess I didn't know this when I first started working on this, but the LLM effectively is entirely stateless, meaning that every time you interact with ChatGPT or whatever, or any of the LLMs, every single time it's a brand new interaction. And it only seems like we have a history because they're actually taking the prompt and passing it back into the LLM every single time. And so getting back to our story, and I'll have to wrap up really quick. It's launch day. We've now created a whole new brand of shoes, and our application developer is trying to figure out how they can incorporate this new generative AI tool that everyone's talking about. But there's a number of hard problems in incorporating that, and I kind of touched on a few of them with the prompts. But how do we incorporate new and private data? How do we provide context? Earlier I showed the customer 360. How do we let the LLM know about the customer? How do we do long-term memory? And then how do we integrate this into our business? And so in this example, the developer has been giving, please don't read any of that. It's just a bunch of JSON for some of the new shoes that the designer has created. And so the developer needs to figure out a way of injecting this shoe information into their website or their application. And so what they've done is they've simply passed in that shoe information into, you can see there's a new microservice that we've launched, the things that are in blue. And we have a topic, the marketing topic. And again, you don't have to read any of that information, but it's pretty boring. They really haven't tackled a lot. They've only just taken that information and passed it into the website. And so it's good. It's a good first pass, but they want to do better. So now that, because we have a Kappa architecture, we can incorporate that customer 360 information. And so you can see that we've now hooked up the customer 360 information into the prompt. And now, again, all of a sudden, what we're doing is we're passing in Anna's details, so Anna Anderson. And the really amazing thing is I passed in that exact same kind of basic JSON information, but I've told in the prompt, I've passed in that fact that Anna is from Brazil, the type of running that she likes to do. And what it's done is it's only shown the four shoes that deal with walking, and it actually incorporates Brazil and different areas of Brazil into the text itself. So that was all generated by the large language model. The developer didn't have to do any of that. Talking about long-term memory, again, this is the area where a customer might be doing a review or chatting to the chatbot. And so again, as I said, LLMs don't have any ability to have long-term memory. And so, of course, we know with the Kappa architecture and Kafka, we can have infinite storage. So it'd be great to be able to pass on those messages into a topic. And so here we have, again, an interaction where somebody has bought some shoes and says, gee, thanks, they were amazing, so amazing they fell apart on the first run, and now I've got 250 pair of shoes sitting by the side of my bed. So there's sarcasm. LLMs get sarcasm. So a lot of sentiment analysis actually scores this as 5 stars. But the LLM actually reads into that and realizes that you're being sarcastic, and it gives a bit of an apology. But again, we can do better than that. We can incorporate the customer 360. And again, apologies for the small writing, but we're injecting now the name of the user, their email address, and now the LLM is responding with their name. It's responding that they're going to provide a discount code to them, and they're going to send it to their email that the system already knows about. And you can see, again, there's just a little bit of information there. We've now launched our shoe company. The shoes are selling really well. And I just want to end on a couple quotes. Again, Yuval Noah Harari in the book *Sapiens* wrote, "Consistency is the playground of dull minds," and I quite like that. In terms of just again, always trying to think about how we can mix things up and be really curious. And so, yeah, I think I just wanted to end on this one image and just really about staying curious and staying open to new possibilities. So, thank you all.